All right. So let me pass out programming assignment 1. And I believe this is due on Friday.
Thursday?
I think Friday.
As President Trump and Secretary of Friday defended.
So PA1 is kind of getting your feet wet with all of this stuff. You don't need to know any C programming to do PA1. You're given the code. But even if you're given the code, there's a bunch of steps you have to go through to be able to complete a programming assignment. So this is working on those other steps other than actually coming up with the code itself. So the main process is, 1, getting connected to the CTEC server, okay, which some of you did successfully, and then the server had some issues. So that'll be the first thing. And then creating this source code, right, PA1.c or whatever you call it, creating this file that contains our source code. We're going to talk about that presently. And then once you've got that, compiling it, so using the GCC command, and then running it, so saying ./a.out, right, to execute it and see what it does. And then step 5 is actually submitting it for grading. Okay, and you're going to submit it on the CTEC server. And nothing's going to get graded till Scott comes back, because he's going to be doing the grading. But you can still submit it usually before then. So we've talked about how to connect to the CTEC server. Okay, SSH or PuTTY or Terminus or some other thing. And don't try to do this on your phone, by the way. Right, it's fine for a quick check to see if your account works and stuff, but actually trying to edit code and run it through most phone keyboards is extremely painful. Most tablets, extremely painful. You really want something with a keyboard as much as possible. So let's go back to the CTEC server, if it'll have us. Nope. Okay. So I'm just going to pretend again that I'm on the CTEC server here. And I'm going to go into my CSE 121 directory, and I'm going to make a PA1 directory, and I'm going to go into PA1. So I'm just in a separate folder that I'm using for programming assignment 1. Yeah.
Would we have CSE 121 already built, or we have to make that directory?
You got to make it. So make dir space CSE 121, or you can call it whatever you want, right? Whatever works for you. This is the nice thing, like I said, about working in computer science in particular, right? I mean, it's so customizable. Right? Most jobs you walk in and you want your desk to be on the left side instead of the right. They're not going to let you just rip out the desk and move it, right? Programming, pretty much you can set things up however you like. And people get really, really particular about this. I used to work with one guy. He had like 20 windows open and they were all color-coded. And he knew exactly what each one meant. And when he needed to do something, he could immediately find it on his screen through the color coding and so on. And that was just what worked for him. He started the day with like 5 shots of espresso and went from there. But you know, customize. So here's my organization. I've got CSE 121 for all my work in this course, and now I've got a folder called PA1. Okay, so our immediate goal is to create a source file that contains some code in it. And the code we're going to write is actually given to you. So it's all of this stuff. And each of these things is something that the C language understands. It's something that the compiler will know what to do with. So about 10 lines of code. And we have to create a file containing this. Okay, and we've already got a PDF file containing it, but that won't work for us. We really need a file that just contains these lines of code. So if you're on a Windows machine, right, you can use Notepad or WordPad or Notepad++ or something like that. But if you're on something like the CTEC server, right, or your own Linux terminal or something like that, we can't run Notepad here, right? It'll probably work just to make me look bad. No, okay, so it's not a built-in command. And how could it be, right? Generally, since we're running things on that machine on the other side of campus, it's not going to pop up windows for us to type into. It's not going to understand our mouse movements and so on. It's really command line based. So there's a series of editors that exist solely to let you create files, put contents into a file, look at the contents, modify the contents. Okay, and there's a variety of editors around, Pine and Tico and Emacs and EX, and the one we're going to use in this course is called VI. And VI can be almost like Notepad. Okay, you can VI a file and you can move around with the arrow keys, and you can take your mouse and you can highlight things and you can cut text and paste it and so on. And that will work, but VI is capable of a lot more than that. Okay, VI is an incredibly powerful editor. It's got full-on programming capabilities inside, macro capabilities, things like that. If you happen to be someone who's been doing computers for a while and you happen to like Emacs, don't get offended by this, but there's sort of this religious war between people who love VI and people who love Emacs, which is another editor. And Emacs is probably more powerful, but it never worked for me the way VI did. And for this course, we're doing VI. So you have a handout that should look like this: basic VI commands. Okay, did I hand that out? Do I need to hand that out? Oh, you don't have a handout for that. It's on the on Canvas. So so go under Files and Documents and VI Basic Commands. Same with Basic Unix commands and so on. All right, so I'll work off of this copy. So VI is another program. What's it written in? It's written in C. And we can use it to edit files. Okay, editing means putting contents into a file, looking at it, modifying it, so on, and ultimately saving it. Okay, so VI space and the name of the file we want to create. That's how we basically start the whole process. So let's create a file. Let's just play around for a minute. Let's just create something called test file. Okay, I hit enter and I get this mysterious looking window pop up. I got the blinking cursor at the top, right? It's really waiting for me to do something. I've got these little blue tildes going down the screen. At the bottom it says test file, new file. Okay, if I want to get out of VI, here's the way I do it personally: :WQ and then hit the enter key or the return key. But you can also do :X, and that does the same thing as WQ, but for some reason I always do :WQ. So :WQ, enter, and I'm back where I was, right? But now if I do an ls, I have something called test file.
So is VI on the server?
VI is on the server, yeah. VI is part of pretty much every Unix installation. And yeah, everything we're doing here is actually on the server, except I'm pretending I'm on the server because it didn't want to connect me. So
It might be back up.
yeah, it comes up for you, but then it still doesn't want to let me in. But yeah, if you're on ctech.clark.edu, VI works there also. All right, so I have a file called test file. Do you remember how we look at the contents of a file? Cat, right? So cat test file, and there's nothing in there, right? Because we didn't actually put anything in. And if I do ls, there's test file. If I do ls-l, that 0 in the middle of the line, that's how many bytes are in my file. 0 bytes, because we didn't put anything in there. All right, so we can say vi test file, and we're back in the file. 0 lines, 0 characters. It's not a very exciting file. So let's come down here on the second page. Inserting or adding text. If I want to insert text, I can type the letter I. And after I type the letter I, anything that I type becomes part of my file until I hit the escape key. Once I hit the escape key, I'm no longer inserting text. So if I type the letter I don't see anything happen. But if I start typing something here, it shows up on my screen. So here's some stuff I'm typing, and if I hit enter, I go down to the second line. All right, and it says until you hit the escape key. So at this point, if I hit escape, watch what happens to my cursor. It's just going to go back one spot. That doesn't have to mean anything to you, but eventually it'll make you feel good. And now if I were to type, here's some stuff I'm typing, it's not going to type that in. Okay, so here's the funny thing about VI. It's got two modes of existence. Okay, when I type an I, it goes into what's called insert mode, and everything I type becomes part of my file. The only exception is if I hit the escape key, that takes me out of insert mode. And it puts me back into the other mode, which is command mode. And command mode is where all of these things have meaning. For example, if you're in command mode and you hit an I, it puts you into insert mode. If you put an A, it puts you into insert mode, but it starts after the cursor's location. So right now, if I say I, and I start typing, it's going to come out right before where the cursor is. So I typed I, if I type 1, 2, 3, it came out before the E. If I type an A, that means append. It means start inserting, but do it after the cursor. So if I type A and I type 1, 2, 3, it comes out afterwards. That's just a minor nuance. Okay, but there's I and A. Those are the two main ones for inserting text. There's also opening. If I want to open a new line on my file, I can use a big O or a little o. So what does that mean? I'm sitting over here and I want to type in a line below this one. Well, I could go back to the next line, I could go back to the very beginning, and I could say I, and I could type in my new line. But I can also just type the letter O, and that says open up a new line and go into insert mode. And now I can type, this is a new line, and hit escape, and there's my new line. Okay, so let me give you my disclaimer at this point about VI, right? This is VI. This is what you probably need to know about VI. Okay? VI is huge. This is a synopsis of basic commands, and it's 1, 2, 3, 4, 5 pages long, right? And that's just a really, really brief synopsis. There's a huge amount of things in VI. You really only need to know about 5 or 10 of them to be pretty efficient with it. But you'd like to be able to do more than just use it like Notepad, which is using the arrow keys and the mouse to copy and paste. You'd like to learn some commands. But my suggestion is, again, when you've got time, not when you're like pressed and you're trying to finish your programming assignment, when you got some time, right, and you're looking for a counterpose, start playing around with some of these things. Go into an empty directory, create an empty file with VI, and start typing things in and play with these commands. And for each person, some of these commands will resonate with you, some of them will just bounce off you, right? :X totally bounced off me when I was learning VI. :WQ totally sunk in. And the things that work for you, right, jot them down on a piece of paper. And don't try to memorize VI, right? Make a sheet of paper with your version of some of these commands, and when you're trying to do something, look it up on your sheet of paper. The things that you end up doing a lot, you'll remember. The things that you never use, don't worry about them. right? Unless you're getting a test on VI, then you gotta, you know, put them down on your sheet and memorize them or something. But for practical purposes, just let your experience be your guide for what's important to you, right? So so I never use the 0 command, right? But I use the J command all the time. So I remember J, 0 I have to think about for what it does, right? But look through this, experiment, make some notes, and you know, if you find yourself doing the same thing over and over and over again, like I want to put a new line below this one, well, you know, I can go down and I can come back all the way and I can say I and type my new line. After about the 50th time of doing that, you're going to get tired of it. You're going to say, there was some way to do that more quickly. Oh yeah, just type in O, right? But it'll be different for each person what you remember and what just bounces off you. So I'm going to go through some of these just to kind of give you a brief example, but pick and choose. So we know how to start VI, we know how to get out of VI. If you want to get out without saving your changes, just say :Q exclamation mark, and that'll just quit. If you say :Q and you've made some changes, it'll say you made some changes, right? So I insert some stuff here and I say :Q, it'll say you made some changes that you haven't saved. If you really want to quit, just add an exclamation mark and that'll quit and not force me to save my changes. So I just lost all my typing. All right, so we know how to start, we know how to get out. Moving the cursor around, so HJKL, okay? This is like, this is the main way to move around inside the editor. And it also works good for playing Unix-based games. So J moves down, K moves up, H moves to the left, L moves to the right. You can also use the space bar to move to the right. Okay, but J is down, K is up, H is back. You can use the up arrows for this. My personal preference is not to do that because it doesn't always work. It'll work on the CTEC server because it's been set up to allow you to do that. But it makes it really easy to just stay in insert mode all the time. And if you're always in insert mode, you can't use all these other commands, right? So, but I'm not going to preach about editor gospel because it's always a personal thing. So you can move around HJKL. 0 takes you to the beginning of the line. $sign takes you to the end. W lets you move one word at a time. All right, so here's some text in my file. I'll save it this time. And let's say I want to change this word haha, right? Well, I can hit the space bar until I get over to haha, and then I can start typing over there. But I can also hit the letter W, and that says move one word at a time. I can hit B, and that says move backwards one word at a time. I can do $sign to go to the end. I can use 0 to go to the beginning. Okay, you can get there by just hitting space, 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 right? But, you know, W is really quick, and B is really quick. So those are other ways to move around. You can also switch to different lines. So if I want to go to line 5, I can type a 5 and a Shift G, and it brings me right to line 5. If I want to go to the last line of the file, I can just hit a Shift G and it takes me to the last line. If I want to go to the first line, that's just 1 and a Shift G. But you don't know what the last line number is, so G without a number takes you to the end of the file. Alright, suppose we have a bunch of stuff in our file. If I want to scroll down by more than just one line at a time, you can use Control D, and that starts scrolling you down. Control U scrolls up. And so these are some of here: Control up, Control down, Control forward and backwards. Up and down go half a screen at a time. FB do a whole screen. Control L is really useful. It basically just redraws your screen. Why is that useful? Well, things can happen. A message might pop up from another program that's running in the background, and you see some stuff appear in here that's not actually part of your file. Control L will say, just redraw this screen the way it should be. Okay, all of these things, Control F, Control L, O, W, B, those kinds of things, they don't work in insert mode. Right? If I'm in insert mode, if I say I and I hit W a bunch of times, I'm just typing in W's. If I hit an escape and I type W a bunch of times, now I'm going forward a word at a time. So two modes, insert mode, command mode. U is an undo. Okay, lets you undo whatever you just did. So I didn't mean to type all those W's in the beginning, I just hit a U, that undoes it. Alright, inserting text, opening, little o opens a line below, big O opens a line above you. I inserts before the cursor, A appends after the cursor. Changing text. So let's come down here to ha ha and say I want to change this to, say, ho ho ho. Right? So I could delete this once we know how to delete, and then I could type in my new text, but I can also say change word, CW, and it'll show me where the end of the word is, and whatever I type in here replaces that word. Again, type an escape to come back into command mode. I can delete a character by typing an X. I can delete a word by saying DW. I can delete an entire line by saying DD. So if I want to get rid of this line, I can just say DD. Most students that I see, if they want to delete this line, here's what they do. They go down to the next line, they come back one line, which won't work on mine, and then they go into insert mode and they start hitting backspaces or something. And then they go too far and it deletes the previous line, they have to type it back in. All you got to do, command mode DD, deletes the entire line. Or if I just want to delete from some point in the line to the end, Shift D will do that. So I'm sitting here on haha, if I type Shift D, it gets rid of everything from that point to the end of the line. Again, it'll drive you crazy if you try to memorize these, right? And there's way more here than you actually need. But some subset of this will probably make you much more efficient in terms of editing your code. And most of these things you can do multiple times. So if I want to go up 10 lines, I can say 10K, and bang, I've gone up 10 lines. Yeah? Yeah, so if I accidentally say like 10 DD, which gets rid of 10 lines, oops, I didn't mean to do that, just hit a U. But U only does one undo. Okay, so if I delete 10 lines and I delete 10 more, then I say U, it may not bring them all back. But it depends on your version of VI. So 10 DD, 10 DD. If I say U, it brings back that first batch. If I say U again, it doesn't do the others. But while I'm editing my file, right, I can say :W anytime I want, and it writes my file out to disk. And now if I say, 25 DD, oops, I didn't mean to do that, right, I can just Q exclamation mark, go back into my file, and my last thing that I saved is still there. Alright, so we can change word, we can replace a single letter by saying R and typing in the letter, we can replace a set of letters by saying Shift R, which lets us pretend we're in overwrite mode instead of insert mode, and it just replaces this is new text instead of the old text. Alright, so it's like when your cursor changes in Notepad. You can delete a single character, delete words, delete lines. What else? I won't worry about yank and paste yet. But there's copy and paste capability. So for example, okay, I believe you. If I delete that, it actually gets kind of like cut into a little paste buffer. And if I come down here, for example, and I type the letter P, that'll paste whatever got deleted last. If I come up here and I delete the word haha, and then I come down here and I type P, it pastes haha right there. All right, the other thing you can do is search. So if I want to search for a string, I can type a slash and then type in what I want to search for. So I can search for ha ha ha, and it'll take me to the next place in the file where ha 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 appears. And if I type the letter N, that says repeat the search. And if I get to the bottom, it'll scroll back to the top and show me there. So now every time I type the letter N, it takes me to a new version of ha ha. And a shift N will search in the opposite direction. And again, there's more nuances to this, but basically slash searches forward for something, question mark searches backward, N searches for the next occurrence, big N reverses the direction. Control G is useful. It'll show me I'm on line 9 of 35, 25% of the way through the file, and I'm in column 12. So if you're looking for a particular line in your file, that can help you know where you are. And there's more in here, but that's sort of a basic synopsis. So we can use VI to write code and edit it and put it into a file. So here's the program that we want to do for PA1. So it's about 10 lines of code, and you can just type this in using VI. And let's just do that. So I'm going to call this PA1.c. Again, C programs use the extension .c. And I need to type, so I'm going to type the letter I to say go into insert mode. And I'm just going to start typing this in from the document version I have. Okay, and then I hit an escape, and I'm going to say :W to write that out. So I've written a C program. Okay, all I did was copy the code from PA1, but it's still a C program. All right, so we've written that. All right, so I'm going to :WQ to get out of here, and that was a mistake. Don't worry about that. Okay, so I can cat PA1.c, and there's my program. All right, so we need to compile this. So to compile it, we just say GCC space, I guess they called it P1, not PA1. How can I change the name of this program to be P1.c? MV, move PA1.c, P1.c. And now if I look, there's P1.c. All right, so to compile, we just say GCC in the name of the program, P1.c. And we got some weird talkback. Undefined reference to main. So there's a typo somewhere.
I think the main was spelled wrong in the first.
Mabe.
And I called it Mabe. Now technically there's nothing wrong having a function called whatever as long as it's a legal name. But main is a very particular function. When we try to run a.out, it's going to look for something called main, and that's what it's going to execute. So this complaint from the compiler was actually saying, I'm looking for something called main and I don't see it. Okay? This is an error that doesn't, a message that doesn't really help you find it. You just kind of have to know when you get a message like this that says collect to, you've probably got something wrong with your main program. But if I said something like, you know, C equals A plus plus B, right, I might get a more meaningful error message like program1.c:10, that means line 10, Colon 8 means column 8, colon error, expected a semicolon before B. Well, the problem's not exactly with B. The problem is that I have 2 plus signs, right? But the compiler will usually get you close to where the problem is. And when you're debugging a program like this, look for the first error message. Okay? You may get 50 error messages, and the last one that you see, that's the least important. You want to go back and look for the first error message, fix that, and then recompile. Because sometimes one error somewhere will cause a whole bunch of other errors to occur. Let me see if I can make that. Right, so here I got 3 error messages, well, 2 errors and a note. Look at the first one, which is line 7. So line 7, well, there's actually nothing wrong on this line, but look right before it, right? And that's where the semicolon was supposed to be that I got rid of. So there should be a semicolon at the end of that int statement. And without that, it thinks that this statement is int a, comma b, comma c, a equals 10, right? Which is confusing it. All right, so fix your errors. Compile your program. If it compiles successfully, it doesn't say anything. It just comes back silently. That's actually good. Okay, so GCC P1.C doesn't give you any output. Now if you say /a.out, and what is a.out? Well, we've got this mysterious file now called a.out. That's the result of the compiler. So if we say /a.out, it executes it and it tells us 10 plus 20 equals 30. That was easy. So that's PA1. And the number 30 doesn't appear anywhere in this program, right? We made 2 variables equal to 10 and 20. We said calculate 10 plus 20, set that equal to C. That's where the 30 came from. And then we printed out A, B, and C. That's what printed out the 10, the 20, and the 30. So it's a genuine C program. All right, so here's the last part. Once your program is working, you need to submit it to Scott for grading. And the way you do that is to use this copy command, copy cp space p1.c space, and then this big long string, /home faculty scost CSE 121 /, and then this is your login ID, but it's your login ID without a number at the end. So this one case only, if your login is jsmith24, just use jsmith or j.smith, right? Don't put the number on the end. And that's just peculiar to this. Now, if you registered for the course fairly recently, this may not work for you. And if it doesn't work, let me know. Let me see what you're doing, and we can make sure that you're doing this correctly. It may be that you don't have an area set up yet to submit things. That's fine. Okay, nothing's going to be graded till Scott gets back. So, so let me know what's going on, and then you can submit once he's back and sets up the upload area. Because I don't have access to the internals of his account. But barring that, you should be able to do this. And then if you type this cat command, you should see a copy of your code. Okay, that kind of tells you that you got it submitted successfully. So questions about that? So this is due Friday. I strongly suggest you try to do this tonight or tomorrow, but absolutely before Thursday, right? So that Thursday when we come in and I say any questions, you can, raise your hand and ask questions, or you can catch me beforehand and we can work out the details. So what is this a.out? So if we try to cat it, it's gibberish, right? It's got some stuff that we can read, but it's mostly just weird looking stuff. And sometimes that'll actually mess up your PuTTY session. If you're running PuTTY, you'll go into weird colors or things will blink or stuff like that. It's what we call a binary file, right? So p1.c, that's a source code file. That's human readable if the human happens to understand C, right? But the compiler GCC translated it into this stuff. So here I'm looking at it inside VI. It's 8,700 characters. That's not huge, right? 8 or 9K. But it's just a lot of things that mean nothing to us but mean something to the computer. This is the computer's language. So it's 8,300 bytes. This little X right here, this tells us it's an executable program. If I try to say something like /test file, it'll say you're not allowed to do that. Right? That's not a program that can be run. Generally, programs that can be run are created by the compiler, so something like a.out. And so that little X is what we call a permission bit. It tells us it's executable. And after you've done this and you've submitted it, if you want to play around with this code, feel free. Right? It's a good excuse to practice with the editor, but also to start exploring some stuff. For example, if I change this to a 50 and this to a 30, right? Not really hard to guess what it's going to do. Right? I'm setting A to 30, B to 50, C should be equal to 80. And when I run this, it tells me 30 plus 50 equals 80. And that was easy. If I were to change C to be answer, it's a totally different looking set of instructions, but fundamentally it's doing exactly the same thing. A is 30, B is 50, answer is a variable that should be equal to 80, and it's going to print out A, B, and answer. That's going to do exactly the same thing. All right, one other comment. You'll probably notice that I do some things up here that I haven't talked about. I have a lot of habits that you can take advantage of. For example, GCC space p1.c, that's not going to kill you to type that in. But if you're typing that in 50 times, it's kind of a pain, right? Especially at 2 a.m. If I hit the up arrow, that will bring back the last command that I typed in. If I hit the up arrow again, it'll bring up the previous command to that. So if I want to recompile, I can just hit the up arrow twice, see my command, and just hit enter. And then if I hit the up arrow again, now it's going to bring up /a.out, and it'll say that was easy. And if that doesn't work, right, I can edit my program. And now I've got 3 instructions here, right? 3 up arrows will do a compile, 3 up arrows will do the execution, 3 up arrows will bring up the editor. And now if I'm trying to get a program to work, right, what am I going to do? I'm going to edit it, I'm going to compile it, I'm going to run it. And I might do that process hundreds of times over the space of a few hours, right? And I can just up arrow, up arrow, up arrow, right? And that's crude. There's much more powerful ways that we'll talk about, like in CSE 224, to set up shortcuts and abbreviations and ways to do things repetitively. But up arrow is a really easy one. And if I type the word history, it'll actually show me a history of all my commands going back, I don't know how many days, but I've got my environment set up to always remember the last 2,000 commands that I've done, so going back to something I was doing quite a few weeks ago, actually. Yeah?
So /a.out, does that mean you're running the program itself?
Exactly.
You're referencing to the server.
So everything we're doing is on the server right now,
Yeah.
right?
Yeah.
And so /a.out is telling the server, okay, find a file in your directory called a.out and execute it. right? So
So dot slash, and then if I listed another program, it would run that program?
yeah, so if I said dot slash test file, it says test file can't be run. If I say dot slash what, it tells me there's no such file called what, right? Because dot means look in my current directory,
Okay.
basically. So it's only going to understand what I mean if I list a file that's in my directory. But if it's not an executable, it'll say permission denied. And if it is executable, it'll go ahead and run it. But if I move to a different directory where I don't have an a.out, and I try to do dot slash a.out, it says no such file.
Why is it always called a.out?
I don't know what the history of that is, but that's the default file name that the compiler generates. And there's ways to override that. You can actually say something like gcc-o my file p1.c. And now I have an executable called my file. And if I say dot slash my file, it runs that program. And I also have my system set up so I don't need to say dot slash. I can just say a.out and it'll just execute it, but CTEC isn't set up that way. But you can set it up yourself. I can tell you how if you like. All right, good enough to get going on PA1? Okay, that was a long 3 hours. Thank you for staying focused. I will see you on Thursday.